request like encryption. And I'm a security engineer, but if you ask me today to develop a web app or an Android app or an iOS app from scratch, I won't be sure that my app will be bug free for sure, because there are lots of things that I have to constantly do. So one of the questions is, why don't we just write method documentation? And I said it doesn't work because developers, they don't have time, and we don't have time to read everything. Like sometimes people just copy code from somewhere else, maybe Stack Overflow. And if the code has the potential vulnerable pattern, then and if you have lots of code in your code base that are potentially vulnerable, then you will for sure have code that has real bugs. So what we found is, what interesting is, like most developers writing on top of this API, the code that they write don't actually deal with security. They just want to render a UI command. Like, I just want to show the UI. Why do I have to care about cross-section? Why that this UI can make people hack my app? It doesn't make sense. And the more requirements we ask the developer to follow, the less productivity they would have, and that would be a major concern. So for example, this is like an example of showing the common. So as you can see, the developer want to show a link to the user homepage and want to insert the comment to the UI. So this is what they do. And this makes totally sense, right? Because this is the API that the browser gives them. If you want to insert a link, this is how you do it. But if you look at it, it has like a list two vulnerabilities. Because the link can be a JavaScript link. So if a JavaScript link, then if someone click on it, the JavaScript will be executed. Even if you escape the link, it doesn't make sense because it doesn't help because the JavaScript link still got executed. And the content can the comment can contain JavaScript as well. And this is very hard for people to know. So they were introduced because developers were forced to use what we call inherently unsafe APIs. Now, these APIs are impossible to use correctly. So, but these APIs are super popular. They are very widely used. And because this is the only APIs available to people before someone step back and think, oh wait, this API is wrong. We should do something else. So looking at the APIs and looking at the observation that the pervasiveness of all the bugs come from the API being used have security consideration that developers have to constantly keep in mind. So we see that we need to fix at the API level. We basically need to arrange so that the APIs no longer permit developers to make mistakes. And so what we want to have is what we call inherently safe API. With respect to a particular vulnerability. So we want APIs that, through design and structure, guarantee that if you cannot write code against the API that has specific class of vulnerability, the code won't combine. And if the code combines, it should be bug free. And that provides us tremendous value, right? Because we don't have to review everything again. If it's combined, it runs, it's bug free. So we only need to review the exceptional use cases where the APIs, the safe APIs that we provide them don't work anymore. And there are some cases like that. So we try really hard to make sure that the exceptional use cases are very rare. And stick out like a sore thumb when we look at the code. So, and we also want to make sure that the API that we provide, the same APIs that we provide, as convenient as possible, as the unsafe APIs. Because if it's very tedious to use, nobody would use it. So that's hurt, that comes back to the point that I said earlier, that developer productivity is a very important consideration in all of these things. So, how do we? So I have the rest of the presentation, I will give you two examples of this API. The first API is something we call the safe HTML type API. So with this API, if you use the API consistently, XSS is impossible. And we have data to show that, well, in 2012, before we developed this API, Gmail has I think 30 XSS, which is crazy, right? Because that means that 30 chances for someone to read all the emails for all of us here, which is crazy. So, and after we developed the APIs, deployed it, I think in 2015, we look at the data again, and we have 1 or 2 bugs. And the bugs are in an exceptional case where after we reviewed the system, the developer add something new, and they didn't, they kind of, bypassed the system we put in place. So that's 30x decrease in the number of bugs that we have, and it really works. The second API that I want to highlight is Think. This is a new API that we developed. It's a crypto API. So I do security reviews, I do product security, but my interest is in crypto. So, and at Google, my team takes care of providing people with consulting and crypto development, crypto analysis. So, and we asked ourselves, why do you have so many crypto bugs back in the day? And this is the reason. So this is a typical snippet that you see how people do, ASGCN encryption in Java. So it's from my point of view now, it has all the red flags. For example, the API asks the user to supply the IV, and this is one of the big red flags, because you're asking the user to provide critical input here. And you expect the user, the developers, to know the properties of the IV. And the properties of the IV is not, it's not really straightforward, right? I mean, in AHGCN, it could be an index, it could be a counter, as long as it's unique, that's okay. But in CPC mode, it must be unpredictable. So all of those problems, the developers have to keep in mind, and no way they can do that, right? And what if they just use 8 bytes, for example? And 8 bytes, what's wrong with 8 bytes IV? If you encrypt more than a million of messages with a single key, you for sure have an IV collision. And at Google scale, an event that happens out of 1 in a billion times would happen 10 times a day. So this is not acceptable. And then for GCN, for example, for this specific instance, the set 64 parameter indicate the length of the tag, the MAC tag. And then if you look at the GCN standard, you would know that, wow, if you use 64 tag, you would have maybe 32-bit security, not 64-bit security. So, and then the next problem is, where does the key come from? So if most of the time we found out people have code the key or store the key directly in the source code. So all these problems, they become very intractable if we try to fix the API. And because this is the API in the Java, OpenJDK, JCE API. And it's tremendously hard to fix them, to convince Oracle that this is wrong, we should deprecate this API and build something else. Because, again, this provides lots of sharp edges, and people can cut themselves very easily without knowing, even knowing. So that's why we developed Ting. Yeah. So comparing to the default API in OpenJDK, we want to make sure that user cannot load like clear text key set at all. Like there's a separate APIs for people that wants to load clear text key set. But if you want to do that, you have to do it wireless. And that's again the point that I mentioned earlier. We want to make sure that it's okay for user to do something dangerous. But if they're doing that, that thing must be flagged in reviews. That thing must get security approval. And we provide our API, for example, the encrypt method doesn't take anything else except the message and the additional data. So all the critical input are provided by the APIs. And this makes sure that we always do the right thing. And the user don't have to look like, I want to encrypt something, I don't know what an IB is. So why do you ask me what is an IB? So, and the APIs, our API has what we call is readability. Because if you look at the API, you know right away what the security guarantees that it provides you. So we give you an AEAD interface, which stands for authenticated encryption with associated data. So this should be safe against choosing cyber attacks. And as a reviewer, as a security reviewer, when I read this code, I know right away the guarantees that the code provides me, and I can match that guarantees with the reality of the app.